first part of the lesson today, we're going to extend on our understanding of complete the square, and we're going to use it to solve. So let's try it out. So here's a trinomial here, and what we would always attempt to do is just quickly run it through the cross and just see whether it's going to happen. And very clearly or quickly, you'll see that it's just not going to work. You're not going to be able to manipulate the numbers to get or crack that middle term. So the next step we've learned on a trinomial like this is to run the complete the square process. Okay, so let's do that. So what I'm going to do is say that this is the same as y equals x squared plus 4x plus 2 squared. So halve it and square it and add it. Then we're going to subtract 4 plus 2. That forms a perfect square, so that's an incomplete square. So this process here completes the square. So we're going to rewrite that as a perfect square, x plus 2 all squared, take 2. Okay, so remember when we're solving, essentially what we're asking for, so solve means to solve for x. Okay, so that's what we want to do. We want to solve for x or find x ints. Okay, and so the x int occurs when y is equal to 0. Okay, so let's do that. 0 equals x plus 2 all squared, take 2. Now, there's two different methods that I'm going to show you here to solve this one. Okay, I'm going to show you my least preferred method first and my preferred method second. Okay, my least preferred method is to convert this into a DOPS problem and to go 0 equals x plus 2 take root 2, x plus 2 plus root 2, then run the null factor law, x plus 2 take root 2 equals 0, in which case x could equal subtract 2 and add root 2, or x plus 2 plus root 2 could equal 0, in which case x is equal to negative 2 take root 2. Right, so that's one method of doing it, and like I said, it's my least preferred method. Right, so let's take this line here, and I'm going to rewrite this line as 0 equals x plus 2 squared, take 2. Right, the method we're going to use is we're going to use inverse operations to solve this. So what I'm going to do is add 2 to both sides. I'm going to go 2 equals x plus 2 all squared. Now what I'm going to do is root both sides. Okay, so I'm going to square root this side and square root this side. I'll square root it and square root it. That leaves x plus 2 on this side. And the square root of 2, in fact, we're going to write as plus or minus root 2. Okay, because remember, what we're talking about here is when we square root, in this situation, we have to take the plus or minus. Now, why is that? Consider I've got x squared equals 9, and what I want to do is solve for 9. So what I do is I square root both sides. Well, x is equal to plus or minus 3. Now, why is that? Consider the original problem. X squared equals 9. Solutions to that is going to be negative 3, because negative 3 when squared is equal to 9, or positive 3 when squared is equal to 9. So don't forget the plus or minus here. All right, so now what we're going to do is subtract 2 from the plus or minus. X equals plus or minus root 2, take 2. All right, now this solution looks a little bit different to those ones there, but in fact it's exactly the same. So we can split this solution, and you don't have to, but we could split it as x equals plus root 2 take 2. We take the plus version of it, and x is equal to negative root 2 take 2. That's the negative version of it. Okay, so let's just try it on another one. Here it is here. So again, these ones are hard when the middle term is an odd number. It produces some fraction work that can get a little unruly. Anyway, let's see how this one works out. So we're going to say that y equals, so fence that off. We're assuming that the cross method doesn't work, which it won't. And we're going to say that this is x squared take 3x. Half of 3 is 3 on 2, and squared is 3 on 2 all squared. So halve it, square it, add it. Close your brackets off and subtract 9 on 4. Take away, and instead of writing 11, I'm going to write that as 44 on 4. Okay, so I already know that I want to, this will be collected up, so I'm just going to write it as 44 and 4. Okay, let's factorize it. So it's x take 3 on 2, all squared, that, and the base. Take away. Now, -9 from that is, well, that's 6, that's 53 on 4. Okay, so again, you could run the difference of perfect squares on this by rooting and squaring, but I think the best bet is to solve it. So let's solve it. So x-intercept y is equal to 0. So 0 equals x take 3 squared, 3 on 2 all squared, over 53 on 4. Now I'm going to add that to both sides. So that's 53 on 4 equals x take 3 on 2 all squared. Okay, so what I'll do is root this side and root this side. That gives me the plus or minus with x take 3 on 2 left there. And we're going to rewrite this as plus or minus root 53 over 2. All right, now I'm going to add the 3 on 2. I'm going to say that that's x equals 3 on 2 plus or minus root 53 on 2, which could be probably better written as x equals root plus or minus root 53 plus 3 all over 2. Okay, so you should have got that if you use difference of perfect squares and null factor law, but for mine anyway, inverse operations is absolutely the way to go for this particular problem. All right, there's your practice questions for the first half of the double.